This is Todd Morse, and I'm going to be presenting on Swipe, open source infrastructure as code for running WDL workflows at low cost. So Swipe is a Terraform module, and if you're not familiar with Terraform, it basically allows you to define infrastructure as code and then apply it to different cloud backends. So because Swipe is a Terraform module, we can work on it as if it's code, but when you actually go to apply it, you can spin up a lot of AWS infrastructure such as step functions, batch, S3, and Lambda really easily and in a reproducible way. So Swipe allows you to run these WDL workflows without having to worry about provisioning a bunch of infrastructure, and it takes inputs from S3 and puts outputs to S3. The benefits of using Swipe are that the infrastructure setup is really minimal. So because we're using a Terraform module, you can actually define even bringing up things like instances to do the actual compute, so you don't need to worry about installing it as a piece of software. As soon as you deploy it, it is ready to run workflows at scale. It's highly optimized for working with large files. We have a metagenomics use case that involves really large indexes, so we've configured the tool to use NVMe drives and download caching, so files can be reused between workflows if they're common to both workflows. We also have cost savings that preserve throughput and latency of the overall workflow. So we use spot instances, and spot instances are instances from AWS that cost less, but they can be interrupted in the middle. We've implemented a strategy to recover in the middle of a workflow in the case of interruption. This allows people who use Swipe to benefit from the cost savings of Spot without having to worry about implementing their own recovery. It also has built-in monitoring and easy integration with other tools via the AWS integration. So if you're running another workflow tool that is a front end on top of these workflows, you can integrate with that front end pretty seamlessly. Some reasons why you wouldn't want to use Swipe are if you're not using AWS or can't use AWS. So Swipe is AWS infrastructure, so it cannot be run outside of AWS. And also if you're running distributed big data jobs, so Swipe is kind of running everything on one instance each step at the end of the day. So if you want something like MapReduce jobs, Swipe is probably not going to help you out. And if you want a completely managed solution. So Swipe has some pretty minimal configuration, but it's still configuration. It's still something you're managing yourself. And there are some turnkey solutions, new ones like AWS Omics, that kind of do everything for you. So if you don't want any management, those might be interesting to explore. So some key technologies that Swipe uses is step functions to coordinate between batch jobs and lambdas. Then the actual compute is run on AWS batch. And within each batch job, we coordinate the workflow. We define the workflow with WDL, workflow description language, and then we run those with mini-WDL, which is an engine that can run those WDL workflows inside of our compute jobs. I'm going to breeze past the history, but it's here if there's any interest in how this kind of rose out of Chan-Zuckerberg infectious disease, and move on to diving into the way the step function is defined. So the step function is defined here, and you can see it. This is kind of what you would see in the AWS UI. And then this is kind of a diagram that shows the various steps where we start with a lambda, we spin up the batch compute, and then you can see that the results are uploaded live to an S3 bucket. And if that failed for any reason, it detects the reason if it failed. If it failed for spot reasons, we are going to retry. And if it failed for unrelated reasons, we are not going to retry. So we are retrying the workflow. And the reason that that is manageable is that we have a feature called call caching. Call caching takes in all this information about the task to build a cache key. So that includes the inputs, it includes the command itself, it includes the runtime to become the cache key, and it maps that cache key to the output files of that task, if such output files exist. So then when we go and run the workflow a second time, we can actually check if the hash exists, and if so, we can just use the outputs from that particular task instead of rerunning. This means when you define your workflow, the tasks are kind of like checkpoints where you can restart from, and you don't need to worry about implementing recovery other than just breaking your workflow into tasks, which you would do in WDL anyway. This allows us to really quickly recover in the case of an interruption and make it easy on the person developing the workflow to deal with those recoveries. One caveat, though, is this requires us to upload everything to S3, including intermediate files that might not be outputs you care about. But if they aren't outputs to the overall workflow, Swipe is automatically going to tag them, and you can configure your AWS S3 bucket to expire things based off of that tag, so you don't need to hold them on forever. It's very easy to get started with Swipe. which is another highlight. This is minimal Terraform that you can run workflows just with this small amount. So for example, you just define some buckets and then you call the swipe module and you are ready to call the AWS API to run your workflows. And you can see that here. This is examples in Python, but it doesn't have to be in Python. You could use any AWS SDK. You just construct the input for the step function and you're good to go. The last thing I just wanted to touch on is that we actually have robust testing where we use an open source library, Modo, to bring up mock versions of the AWS services. So we can actually run from end to end all of this infrastructure integration stuff in our CI/CD and for local development. This allows for deploying with confidence and rapid iteration for when we're developing Swipe. And we're planning on adding some additional features in the near future, like per task notifications, as well as some optimizations around cost savings with compute environments and Spot, and supporting multiple compute environments. I would like to thank everyone who contributed to the project and the Chan Zuckerberg Foundation for making this possible. It was really a team effort, and thank you to everyone who was involved.